Hello everyone, this video's topic is tools for solving equations and review. As we move into solving equations, these are going to be some things that you want to be familiar with and you might have already seen them before, which is great. Questions to ponder as we go. How can we use the distributive property and combine like terms to create equivalent expressions, make sure the math doesn't change even though it looks different, and then also how can we check if a solution is correct? Let's move on to our notes section of the video. Starting with our vocabulary, our first term, when a group is multiplied by a number, you can multiply each part of the group and then add. That is known as the distributive property, which you might have heard before and we'll go into a little deeper later in the video. Secondly, the number multiplying a variable, it's next to the variable. We say that is the coefficient. The coefficient. For example, if you had something like 3x, the coefficient would be 3. That's 3 times x. That's our coefficient. Next up, numbers or variables that are separated by a plus or a minus sign. We say that is a term. In mathematics, a term. So if you had something like 4 plus 2x, each of these are separate terms. This would have two terms. The 4 is one term and the 2x is another term. Next, if we look at a statement that shows two math expressions are equal, we call this an equation. And we always know we have an equation when we have that equal sign. Equation equals. It shows two things are equal. Last term, a value that can be put in for a variable that will make an equation true. We say this is a solution, something that will make the equation work. Let's take a closer look here at the distributive property. So we use the distributive property when a number is directly next to a group, like this 2 is next to this group in parentheses 3 plus 1. That means we can use the distributive property. We multiply each term by the outside number and then we combine. So without using distribution, you might say, let's take that 3 plus 1 in parentheses and change that to a 4. That would change this to 2 times 4, which is 8. That would give us an example without distribution. Now let's check to see if the distribution holds. With distribution, we actually take this 2 and we multiply it times the 3 and times the 1 separately. And you can see that gives us 2 times 3 plus 2 times 1. Then if we multiply those out, 2 times 3 is 6, 2 times 1 is 2. That gives us 6 plus 2. And then finally we get a solution of 8, which we could see works out. As we saw, without distribution we got 8, and with distribution we also get 8. Now you might say, why do distribution if you could just do it this way? But once we get variables in the mix, that's when it becomes a little bit more important. Like our example right down here. We have 3 times the whole group 2x plus 7. So what we do is we take that 3 and we multiply it to the 2x and we multiply it times this 7. That gives us 3 times 2x plus 3 times 7. And when we have this 3 times 2x, we just multiply 3 times 2 to get 6x, and 3 times 7 gives us 21 and a solution of 6x plus 21. You try that process out in these next two, and then we'll go over them together. Looking at the first one, we should add 5 times 2, and then distribute that out to get plus 5 times 4x. And 5 times 2 is going to be 10, plus 5 times 4x. 5 times 4 is 20, so that'll give us 10 plus 20x. And it's okay if you did 20x plus 10. In addition, we can move things around, but this is what we should have got. Looking at the next example, we want to distribute the negative 6. that would be negative 6 times 10x. Then also distribute to the minus 4. Notice that we have a negative 6 times a minus 4, or a negative 4. So that negative times a negative is going to become a positive 6 times 4. Or you could have left it negative 6 times negative 4. Either way will become positive. And then we get that negative 6 times 10x is negative 60x, plus 6 times 4 is 24. So negative 60x plus 24 would be the distributed version of that expression. As you get more comfortable with this, you might even be able to skip this middle step of rewriting. You can just do 5 times 2 in your head to get 10, and then plus 5 times 4x, 20x, and just kind of skip to the end doing some of that work in your head. That's okay too. But if you struggle with your multiplication or integers and things like that, it might be a good idea to write it out until you start getting the hang of it. Some tips, things to remember. Do not forget to check your negatives / minus signs like we did up here. Sometimes that negative times a negative will become a positive, and you need to remember that. When there is no visible coefficient, we use a 1. We use a 1. So for example, down here we had negative 2 times x minus 7. Notice there's no number, there's no coefficient next to this x multiplying. So we can put in a 1 because 1 times x stays the same. 1 doesn't change anything in multiplication. And then you can distribute from there. In this case, negative 2 times 1 would be negative 2x. Minus 7, negative 2 times minus 7 is plus 14. And it would distribute out just like that. If you flip your page over, you will come to the section that says combining or combine like terms. So in combining like terms, use this to get rid of extra terms in a math expression. If you had 1 plus 1 plus 1 plus 1 plus 1 plus 1, etc., it might be easier to just say 10. That's getting rid of those extra ones. Same thing, but not changing anything. To combine, make sure the variable term is exactly the same. Let's look at some like terms here. 2 and 7, those are like terms. 3x and 5x both have 1x in them. Those are like terms. Negative 52 and 17, there's no variable term there, like terms. 4y and negative y both have a y as their variable term, so those are like terms. Here's some non-examples. These are not like terms. 2 and 7x. One does not have an x, one does. Not like terms. 3 and 5x, same thing. Cannot combine these. These are not like terms. 3x and 4y. Both have a variable, but they are different variables, not like terms. 12x and z, same difference. One is an x, one is a z. The variable has to be exactly the same to be considered like terms. Let's take a look at our examples down here. First off, we have 3x plus 5 plus 2x minus 1. Let's start by identifying our like terms. Well, I have 3x and 2x. Both have the variable x, so those are like terms. I also have 5 and minus 1. Those are not like terms with the 3x and 2x, but those are like terms with each other. Both do not have a variable term. So first, if I take this 3x and 2x, I can combine those. 3x plus 2x, that's going to give me a 5x. Perfect. And then if I take my other set of like terms, 5 minus 1, that's going to give me a 4 or a plus 4. So this expression here can kind of simplify. We can combine those like terms. 3x plus 2x is 5x. 5 minus 1 is 4. Looking at the second example, it looks like we have like terms of x and minus 3x. I always like to do the variables first, but again, you can do it either way. Next, we have 8 and 4 that are like terms. So starting with those variables, x minus 3x, 1x minus 3x is going to give us a minus 2x right there. And then the 8 plus 4, that's where we get that 12 from. Just as a reminder, when we don't have it, we put a 1 right there. Whoops. We put a 1 kind of right in front of that x. So again, we end up with 8 and the 4 get combined to give us 12, and then 1x minus 3x is going to give us a negative 2x or a minus 2x. You could have also done negative 2x plus 12, again switching those around. So that's combining like terms. Try your hand at these two problems just below. All right, looking at problem A, it looks like we have like terms of 2x and 4x. 2x plus 4x is going to be 6x. And then this term of 2, which does not have another term to combine, so we would just leave it as plus 2. So that becomes 6x plus 2. For problem B, it looks like our variable term is a negative x plus 5x, or a negative 1x. And then we have other like terms of 10 plus 2 minus 1. I'm going to start with the regular term here without a variable. 10 plus 2 is 12. Minus 1 is 11. So that's going to become 11. And then I have the minus 1x plus 5. That's going to become a plus 4x. So I have 11 plus 4x for problem B. Some things to remember, tips. There are not always like terms. In this case, you can leave it as is. For this example, we had a 2 that did not combine with anything, so we just left it as plus 2. That is okay. When there is no visible coefficient, we use a, you know it, 1. We did in some of these examples up here, just like this minus x or this plus x. We just add a 1 right in front. It helps us a little bit with our addition or subtraction. Moving on. Lastly, checking a solution. To check a solution, we want to put the solution in for the variable and check if the equation is true. If the equation stays equal, the solution is correct. That is a good solution. That works. Let's take a look at this example. Is the given solution a solution to the equation 2x plus 1 equals 5? We have x equals 1. We also have x equals 2. We're checking if these work for this equation, 2x plus 1 equals 5. So here's what we did. We take this x equals 1 and we switch it in for that x there. You can see instead of 2 times x, we have 2 times 1. Then the rest of it stays the same, plus 1 equals 5. So we switch that 1 in for the x. Then we can just kind of simplify the expression a bit. 2 times 1 is 2. Then we have plus 1 equals 5. And then 2 plus 1 is 3 equals 5. Does 3 equals 5? No. So this is not a solution. No. We'd say no. X equals 1 is not a solution. If we did this with x equals 2, we're going to do the same thing. Take that 2 and plug it in for the x in our equation. So instead of having 2 times x, we'll have 2 times 2. Then the plus 1 equals 5, plus 1 equals 5. Switch that 2 in for the x. Then we have 2 times 2 is 4, plus 1 equals 5. And 4 plus 1 is 5 equals 5. So is this a solution? Yes, definitely. 5 does equal 5. Try these two down here on your own. And I made a quick change here. Your equation should be 5x equals negative 25. And you're checking the solution x equals 5 and x equals negative 5. See if either of those work for this equation. Okay, for this first one, we're going to take this x equals 5 and plug that in. That'll give us 5 times, instead of x, I'm going to put in that 5. And I want to check, does that equal negative 25? Well, 5 times 5 is positive 25, which does not equal negative 25. So this is a no. That one doesn't work. Let's check out that negative 5 though. Why not? That'll give us 5 times, instead of x, we're going to put in negative 5. Does that equal negative 25? And here we do have a positive times a negative. 5 times negative 5 is negative 25, which does equal the negative 25 that we want. So yes, this is a solution. I hope you take some time to write your summary at the bottom answering the questions on top, summarizing the concepts we covered in the video today. Please reach out with any questions. I'm always here to help.